The Interface Segregation Principle states that clients should not be forced to depend on interfaces that they do not use. And this principle encourages the creation of fine-grained interfaces that contain only the methods required by the clients that use them. It helps to prevent the creation of fat interfaces that force clients to implement unnecessary methods, leading to cleaner and more maintainable code. So this may sound confusing again, but actually this principle is pretty straightforward. So let's consider an example that involves 2D and 3D shapes. And initially we're going to violate this interface segregation principle, and then we are going to refactor that code to adhere to the principle. So first of all, we're going to create an interface called iShape. And this is going to contain methods for calculating certain properties on a shape, such as area or volume. Okay, so now what we're going to do is we're going to create a circle class, a concrete circle class, and that's going to implement this iShape interface. Okay, so we're getting a red squiggly line here, which means that we need to implement this interface, or implement the methods on this interface. So a circle class is going to have a radius property, and what we're going to do is to calculate the area of a circle, we just quite simply do pi r squared. So we're going to return pi times the radius to the power of 2. And then for calculating the volume, well, here we have an issue because circles don't actually have volumes because they are a 2D shape. All 2D shapes don't have volumes, they only have areas. So here we're being forced to implement this volume method from iShape, because iShape states that we must implement a volume method, otherwise we'll get an error. So what we're going to have to do here really is we're going to return an invalid operation exception, and we'll say that volume is volume not applicable for 2D shapes. Okay, so that is the circle, and now we're going to create a 3D shape now called sphere. So basically a ball, and this is also going to implement the iShape class. The iShape interface, and we press Command full stop or Control full stop, and we're going to implement the methods on this interface. So to calculate the area of a sphere, we have to do the radius to the power of 2 times pi times 4. That's just the equation for calculating the area of a sphere. So I'm just going to paste that in. So we have 4 times pi times the radius squared, and then the volume of a sphere is this equation. So it's 4/3 or 4/3 times pi times the radius cubed. Okay, so 4/3 pi r cubed. Okay, so this all looks okay. I think what we'll do next is we will create, we will actually use this solution. So let's create a circle. If we come into program.cs, and we will create a new circle from here, and we'll set the radius equal to 10, and let's log the area, and let's also log the volume. Okay, so according to VS Code, we have no problems here. This code should be safe to run, but if we run the code, we can see that we get an exception because volume is not applicable for 2D shapes. We are in our program we are calling circle.volume, and VS Code even suggests that we can call this function, this method, and everything looks okay, but when we run the code we have a problem. So really this volume method should not exist on Circle because it really, well, so all 2D shapes don't have a volume, so it just doesn't make any sense. It's making our code more prone to bugs by allowing us to call this method on a circle. So it's easy to see that how violating this interface segregation principle can introduce bugs into a program, because above everything looks okay until we run the program and then we get the exception thrown. Because this I-shape interface is forcing us to implement volume methods on all of our shapes, even when it's not relevant. So how can we solve this problem? So let's refactor our code. So what we're going to do is we're going to segregate this I-shape interface into two separate interfaces. So we're going to create a I-shape 2D and an I-shape 3D. So this actually can be changed to 3D because 3D shapes have both an area and a volume. So I'm just going to rename this file to I-shape 3D. And I'm going to create another interface called I-shape 2D. And 2D shapes only have an area, they don't have a volume. Okay, and again this should be an interface, not a class. Okay, so now we've segregated the I-shape interface into two separate, smaller, more sort of fine-grained interfaces that are more specific, okay, rather than large and sort of general. And now what this allows us to do is in our circle class we can implement the I-shape 2D, and we can remove this volume method because we are no longer being forced to implement a volume method. And then in our sphere class we can implement the 3D interface. And now if we go back into our program, we can see if we try to call volume on a 2D shape, we are now getting an error. So VS Code is straight away saying this method does not exist, basically, and it shouldn't exist because 2D shapes don't have volumes. So as you can see, the interface segregation principle ensures that clients are not forced to depend on methods that they do not use. Clients can now depend only on the interfaces that they need, promoting better code and reusability. And if you are unsure on what a client is, a client essentially just means classes that are using the shape interface. Okay, so for example, a circle is a client of the I-shape 2D interface.